Welcome! My name is Marcel Costantini, and together with my colleague Flavie Romach, we will talk to you today about the projects we're working on at the European Space Agency's Astronaut Centre's Extended Reality Laboratory, also known as the ESA-EAC XR Lab. The European Space Agency and its Astronaut Centre are currently preparing for human exploration of the Moon and, ultimately, Mars. EAC is the center of excellence for astronaut training, operations, and space medicine, with more than 30 years of experience. It supports International Space Station missions and prepares for human to fly again beyond low Earth orbit. To advance human spaceflight, ESA investigates the applications of immersive technologies. The XR Lab was therefore created in 2015 to advance knowledge and development of XR technologies and ensure that they benefit to everyone in human spaceflight. The focus is both on training for the International Space Station and for preparing for the human deep space exploration. Here you can see the main projects that we're driving or involved in. We are working on several tools aimed at improving astronaut training for the International Space Station and about robotics and its external layout, that's Jive, or medical training, that's the human physiology and anatomy one, or maybe, quite a few spacewalk training tools. Then, for human lunar exploration, we're working for tools supporting the Gateway Station module design, for preparation of planetary analog missions, exploration of new concepts of operation on the Moon surface, and planning of experiments. Don't worry, we have handpicked only a few of these projects to show you further details on. And first is Jive. It's a collaboration between the XR Lab and NASA's Johnson Space Center. It explores the best implementation of tools for astronaut robotic instructors to aid them in delivering their lessons. Jive is currently being used together with the classic Dynamic Skills Trainer to train and refresh astronauts' knowledge on robotics operation of the Canadarm2, depicted here. This both include commanding the arm as well as getting familiar with the external elements of the station, like its various modules. Right now, a comparative study with subjects from ESA and EAC and NASA's Johnson Space Center is ongoing to compare the traditional GRT and robotics training in VR. Specifically, effects on training time and retention levels are investigated. It's not done, but results so far point to Jive reducing robotics skills training time from 22 to only 12 hours. Now, our medical training tool. It aims to enhance the human physiology and anatomy training, which is part of the basic medical training for ESA astronauts, and it has the various features. For instance, collaboration between VR and non-VR users here, or maybe even more valuable, it has interactive visualization and 3D models of the human body that a medical textbook could only dream of. And last, for VR astronaut training, we've got spacewalks. Their immersive technologies actually bring visual context that cannot be reproduced otherwise. Therefore, we aim these softwares to complement the spacewalk training done in the neutral buoyancy facility. That's our 10 meters deep pool at the Astronaut Centre. And also, on the picture on the left, you can see a training hub. It's inspired by a museum, and there, astronauts can be shown the theoretical part of the training. Now, beyond low Earth orbit, the International Habitat Module of the Lunar Gateway is one of the many contributions of ESA to return humans to the Moon. Its construction is entrusted to Thales, and their team in Turin, in Italy, collaborates with EAC in designing the module. So here, VR is being used in Turin to allow astronauts in Cologne to experience multiple versions of the module's interior design and perform ergonomic assessments and provide insights without having to travel to Italy. Moving on to the lunar surface, Pangea VR is a collaborative and portable tool which complements analog training. In fact, instructors can now train 3 students at a time to traverse a natural landscape of the moon analog by foot by showing them a bird's eye view in VR. Now, before I leave the floor to Flavie, a quick anecdote. For portability, we had to use the Oculus Quest 2, but we still needed to be able to display an 800 meters long photogrammetric model of the landscape. No tiling of textures here. It had to be unique data on every point of the ground. So I'll leave you to imagine the amount of optimization needed to maintain correct performances.
Vortex explores VR options for robotics training for exploration. Its approach is inspired by model-based systems engineering. It accurately models the lunar surface at human scale to assess operational constraints and opportunities related to robotics. It has already provided with novel insights when it comes to robotic arm operations on the moon. The lunar surface is an opportunity for crew to control the robotic arm while in EVA from the best suited location. In fact, this is not possible when in outer space, where the crew member needs to be mechanically attached to the space station at all times. Vortex has also proven to be an effective tool for outreach. Luna VR is an architectural visualization in VR of the lunar analog facilities planned by ESA and DLR to be constructed in front of the European Astronaut Centre in Cologne. You can see here on the slide on the left-hand side a representation of Luna and its regular testbed area in VR. The application is meant to aid designers, engineers, and architects during the planning and design activities prior to construction. VR in this case is very beneficial because it allows to simulate new functionalities and devices without actually having to physically build them. Moreover, it allows to simulate effects that cannot be simulated on Earth. And it allows users of this facility to plan, to prepare their experiments beforehand by accessing a virtual Luna facility. FlexXR, which stands for Flex Up Extended Reality, pushes the boundary of architectural visualization as it creates a partly functional digital twin of FlexUp, which is an integral part of the Luna facility, which I mentioned earlier, and you can see it here on the left-hand side, as it enables collaborative design reviews for designing, planning, and configuring scientific experiments, as well as planning training activities and testing the usage of a future facility. Several lessons have been learned throughout the development of these XR applications, namely that collaboration adds more value to XR software than it had been anticipated, that it is paramount to consider immersion early on in VR software design, as together with control scheme design, these have a huge impact on the user experience, and that today, unfortunately, VR is not yet considered a standard tool. To make VR interaction even more natural, we plan to integrate exoskeleton, vibrotactile devices, and haptic suit into future VR application and into our current VR applications. And we would like to focus on, and we'll focus on, healthcare and space to enhance onboard treatment capabilities. This brings me to the end of this presentation. Thank you very much for your attention.